Okay, this is 2016 number 1. Who's messaging me right now? You saying things? Isn't rate in, rate out not going to be on? Yeah, but I want to do this one just because it has a table in it. Make sure we know how to do that and all that stuff, okay? Yeah, specifically part D. I really think part D is going to happen to you guys. So while, yes, you don't need to know the integral of a rate in is how much water came in, specifically. But this has some good stuff in it, so let's do it. And you guys already know all that junk. All right. Get out of here. Turn this off. Okay. So they do tell us water's pumped in at a rate W of t, right? And water's removed at a rate R of t. So it's the rate they're removing it. So the integral of that is the amount they've removed, right? Okay. R is differentiable and decreasing. That's alliteration, and it's important for us in this question, I imagine. Cool. Select values RT are shown. At T0, there are 50,000 liters in the tank. So estimate R prime of 2. We've seen this several times. R prime of 2 is going to approximately be the rate of change where 2 lies, so between 1 and 3, the average rate of change. So that is 950 minus 1190 over 3 minus 1, which is 950 minus 1190. I don't know, what is that? 50, 150, 240. Great. But it's negative 240 over 2, which makes this negative 120. And because that's an estimate for R prime, and R is liters per hour, so this is liters per hour over hours. So this is liters per hour squared. That's part A, super easy. I hope you get one of those. Use a Lever-Riemann sum with 4 subintervals to estimate the total amount of water removed. So that's just the integral from 0 to 8 of R of t, right? So we'll do B down here. We're going to integrate from 0 to 8 R of t dt. And that's approximately, and we are using what, a left hand? A left-hand Riemann sum. So the first interval is 1 times 1340 plus the next interval goes from 1 to 3. So that's I don't know, I'm using brackets here. That's a base of 2 times a height of 1190 on the left. Plus, we're going from 3 to 6. So that's a base of 3 with a height of 950. Plus a base of 2 with a height of 740. Right? And we're going to leave that just with liters at the end. Cool. That's how you do it. There you go. All done. Then it says, is this an over or under estimate of the total amount of water removed? Well, again, we did a left-hand sum. Let's just draw what R of t looks like. They told us it's decreasing, right? So it's just a decreasing function. And we did left-hand intervals. So that means on any interval, here's our interval, we took the left-hand height and made it a rectangle. Well, this is an overestimate. You can see the rectangles will be above the curve. And that's all I got to say. This is an overestimate since R of t is decreasing. Look at my chicken scratch. And I used a left Riemann sum. So like I said, all right, part C. Use your answer in B to find an estimate of the total amount of water in the tank to the nearest. Well, that's just going to be, so to do this, that would be the 50,000 that was in there, right, or 5,000. 50,000 that was in there, minus how much we say came out, which I don't even know. Let's just call this whole big number here K. All right, so minus K, that's all the water that came out, plus the water that came in, which would be 0 to, what, 8 of the rate in, which is W of t. So it's the amount that was there minus what left plus what came in. I don't know what this is. You would do it on a calculator. But I'm going to skip over it for right now just because we don't particularly care about handling that kind of question, I guess. Right? Well, let's just make sure y'all can. I don't think you'll have to integrate on a calculator this year. I'm just going to do it, though, just so this video will be here completed. Oh, that means I got to find out what that stupid K is. All right. All right, let's clear that out. And we have 2,000. Don't let me mess this up. 2000 e to the negative t squared. E to the negative x squared over 20. Okay, so I can quit. So we want to integrate that, which is math 9, remember that, from 0 to 8. We're going to put in y1, and dx. So this is the amount of water that came in, right? We're going to add 50,000 to that. Boom. And I'm going to subtract off this whole stupid number here. I could just use k, but I'm going to write out what this is since I'm using my calculator anyway. 1340 plus 2 times 1190, right, plus 3 times 950, plus 2 times 740. And if I didn't mess it up, we get 49,786. It says to the nearest gallon, right? Oh, liter. 49,786. So make sure I'm not rounding it correctly here. Nope, liters. Okay. Equals. Okay, so that's that. D is the question I really want to talk about here. D says, and this, so stick with me. It says, is there a time when the rate at which water is pumped in is the same as the rate at which water is removed? So if they ask you this year or any year, future kids, to see if two functions ever have to be equal and it's from a table, what they really want you to do is IVT. All right, so if they're asking you, must these two things be equal? Here's how you're going to handle this. We want to know, does R of t, the rate in, or the rate out, ever equal W of t, the rate in? That's their question. So if WT is equal to R of t, okay? Now here's something I expect them to do. This sounds like a hard question, but it's not. It's just IVT. We just got to get this in the right format. What you should do is rather than dealing with two functions, one on each side, let's move it over. Now we just have one function. Even though it's W minus R, it's one thing has to equal 0. So if I can show that this thing here, W minus R, goes from negative to positive or from positive to negative, then it must go through 0. And if it must go through 0, then W and R have to be equal somewhere. That's how you attack that question. And just use the interval they gave us, all right? So I'm going to draw it up here just so we have more room. But the question again is, will these things ever be equal? Is the same exact thing as will this difference ever be 0? And what's nice about that is they're asking us from 0 to 8. So we know W of 0. If you drop a 0 into there, you're going to get 2,000. So W of 0 minus R of 0 is equal to 2,000 minus R of 0 is in the table, 1340. That's going to be 660, but it's just greater than 0 is all that matters. If we do this at 8, W of 8 minus R of 8. This is going to be a negative number, but I got to find W of 8 because I need the stupid calculator for that. So we need Y1, boom, of 8. That happens to be 81.524 minus R of 8 is 700. And you can see that's going to be negative. Let's just find it. Minus 700 is negative 618.4. Let's write this out. Negative 618.4 something. 476. But regardless, it's negative. Okay, and to make this even easier for ourselves, I might name this function something. I might name this like, again, I'll pick a letter that hasn't been used in the question. I'm going to call this f of 0. I'm going to call this f of 8, and this function up here is just f of t. All right, I'm just going to name it something, so now I can just talk about f. Okay, so you're going to write f of 0 is positive. Actually, you can write like this. Yeah, let's just write like this. And f of 8 is less than 0, right? Now, IVT happens if our functions are continuous. So we know that W and R They tell you both, let me see here, that they're differentiable, right? It tells you R is differentiable, R is differentiable decreasing, okay, because W and R are both, that's a D, are both differentiable. And thus continuous, right? What? Continuous, whatever. Then F, because F is just made up of W and R, is also continuous. And differentiable. We just care about continuity there right now, okay? All right. So, by IVT, f of x equals 0 at least once. So it has to happen at least one time. Which means W of t has to equal R of t for at least one time. Whew, okay, so there's a lot of writing there. You might be able to make that a little bit more concise, but the main thing is if they ask you, does a function ever have to equal another function? Key thing is move them both to one side and see if that difference will ever equal 0. Usually what's going to happen is at one endpoint it's positive, at the other endpoint it's negative, which means somewhere it has to be 0, which means W and R, or whatever functions they give you, W, R in this case, have to be equal at least once. Okay.